Good afternoon. Let's cover our topic today on physical chemistry. That is, we shall start by the definition of the. Good afternoon. Can you hear me? Can you hear me?
Loud and clear.
Okay. I'm dealing with physical chemistry and the branches of the physical chemistry. I will talk about the thermodynamic, the interrelationship between the branches of physical chemistry and those other branches of physical chemistry. That is the quantum chemistry, the statistical chemistry, and the kinetics. So as you can see from my road there, we have thermodynamics, that is the microscopic science that studies the interrelationship of the various equilibrium properties of a system and their changes in the process. Then there is the quantum process, the quantum chemistry itself, the mechanics that's applied through the atomic and the structures of the molecule. Then that one we can do with the kinetics. If you hear about the kinetics, that one will be the rate of the chemical reactions and the diffusion changes. So as you can see the flow there, the flow there down there in the next slide, we have the thermodynamic going to the kinetic wave. We start from the statistical mechanics of it. We could go to kinetic. The quantum chemistry will go to kinetic. That is we have seen that is the reaction of the chemicals and the rate of the reactions that they will deal with the kinetics itself. So we in physical chemistry that we can ask ourselves why, because it is applied in the engineers, that's the chemical engineers, the use of thermodynamics to predict the equilibrium, the composition of the reactions, and the mixtures of the kinetics. We can use to calculate how the product will be formed. That's why we are dealing with those interrelationship between the kinetics and the physical chemistry and the quantum chemistry. Then there is the principles of the thermodynamics, the phase equilibrium, to design the separations procedures and such as the fraction distillations. Then there is the thermodynamic itself. So the thermo, as you hear the one thermo itself, you can know it's about the heat and the power. So it is the study of the heat works and the energies and the changes in the product in the state of the system, the temperature, and the key properties it takes. So we can define this as the relationship of the temperature to the microscopic properties of our system. You can see the diagram down there about the manometer and the way they are using the flow of the reactions of the chemicals, the temperatures, the way they rise, as you can see in that picture down there. Then you can see that the system itself, the way it was, it could be open or closed. It can be an isolated, non-isolated. The system, as you can see, as you have seen the previous lines of the diagram. There is the wall that is confining the system, the rigid one and the non-rigid. That's the movable. Then there is the permeable and the impermeable. I hope we are continuing together. Then there is the adiabatic and the diabatic. The thermal the conducting itself. So we can see the control of the volume in those two diagrams that are there, three diagrams that are there. You can see the flow, the reaction, and the movement, the way they move, and that one that has the cold water from the water heating itself going up. There is the rise of the temperatures, the surface, the control of the surface, and the way the chemicals move around at the rise of temperatures due to the kinetic energy. Then we can see in the next need there is about the equilibrium, the microscopic properties of the isolated system itself, the microscopic properties of the non-isolated system as it remains constant with time. So we can see that if there is a rise in temperatures, we can keep one of the system that is at constant with the time. When the system itself is removed from the contact with the surrounding itself. So we can see now the thermodynamic equilibrium as we started seeing it. So there is the mechanical equilibrium, there is the material equilibrium and the thermo equilibrium. The properties of the system that remain constant with the time when there is an adiabatic wall. So in the next, we can see that some of the properties that are characterized by the states of the equilibrium. Then there is a